In this video, I will be solving a previous year problem of AMC 10A. So let ABCD be positive integers such that GCD of A and B is 24, GCD of B and C is 36, and GCD of C and D is 54, and 70 less than GCD of D comma A is less than 100. So by using this information, we need to find which of the following must be a divisor of A. So first, if we are having two numbers n1 and n2, and if we have to find their GCD, so first we need to prime factorize. Suppose if n1 has a prime factorization of p1 to the power alpha 1 into p2 to the power alpha 2 and so on till pn to the power alpha n, and if n2 has its prime factorization as p1 to the power beta 1 into p2 to the power beta 2 and pn to the power beta n. So the GCD of n1 comma n2 will be p1 to the power minimum of alpha 1 comma beta 1, p2 to the power minimum of alpha 2 comma beta 2 and so on, pn to the power minimum of alpha n comma beta n. So that means, so if we consider the GCD of A and B, so GCD of A and B is 24, which is 2 cube into 3 to the power 1. GCD of B and C would be 36, is given as 36, so 2 square into 3 square. And GCD of C and D is 54, so that means it is the prime factorization would be 2 into 3 cube, 2 to the power 1 into 3 cube. So that means clearly like A and B are having 2s and 3s in their prime factorization. So if I consider A as 2 to the power some alpha 1 into 3 to the power some beta 1 into some k1, so we need to ensure that 2 times k1, alpha and beta 1 are the maximum possible 2s and 3s respectively in that prime factorization. So GCD of 2 and k1 would be 1, and GCD of 3 and k1 should also be 1. Similarly, if I take B, C, D as well, 3 to the power beta 2 into k2, 2 to the power alpha 3, 3 to the power beta 3 into k3, 2 to the power alpha 4, 3 to the power beta 4 into k4. And again, GCD of 2 and k2 is 1, GCD of 3 and k2 is 1, GCD of 2 and k3 is 1, and GCD of 3 and k3 is 1. And similarly, GCD of 2 and k4 is 1, and GCD of 3 and k4 is 1. So that means there should not be any common factors, especially with 2 and 3 in these residual parts k1, k2, k3, k4. So that means, so the GCD, this GCD is nothing but, so if these are the factorizations of ABCD, so then the GCD of this A and B, so that is nothing but 2 to the power minimum of alpha 1 comma alpha 2 into 3 to the power minimum of beta 1 comma beta 2. In the same way, 2 to the power alpha 2 comma alpha 3 into 3 to the power minimum of beta 2 comma beta 3 and 2 to the power minimum of alpha 3 comma alpha 4 into 3 to the power minimum of beta 3 comma beta 4. And GCD of D comma A, we only know that the range is in between 7 and 100. So the GCD of D comma A, we can assume it as 2 to the power minimum of alpha 1 comma alpha 4 into 3 to the power minimum of beta 1 comma beta 4. So that's what we can comment about 2s and 3s. But apart from 2s and 3s, we can also have a common, like something in common which we don't know. But if we consider GCD of A, B, B, C and C, D, we are explicitly given that 24, 36 and 54 as their GCDs. So therefore there won't be any common factors apart from 2s and 3s. But whereas in D and A, we are just given the range from 70 to 100. So there can be a common factor k such that the GCD of 2 and k is 1 and GCD of 3 and k is 1. So something other than 2s and 3s can be there as a common factor which we don't know. So that's why I'm considering it as k. So with this information, so we are having minimum of alpha 1 comma alpha 2. So if I consider the exponents, So basically minimum of alpha 1 comma alpha 2 is 3, and minimum of, so if I note down the minimums, so minimum of alpha 2 comma alpha 3 is 2, and minimum of alpha 3 comma alpha 4 is 1. The same way minimum of beta 1 comma beta 2 is 1, and then this is 2 and 3. So beta 2 and beta 3 is 2, and beta 3 and beta 4 is 3. So from this we need to determine minimum of alpha 1 comma alpha 4, and from this we need to determine minimum of beta 1 comma beta 4, so that like we'll get some idea about the GCD of D and A. So if we examine these three, like first three, so we are having alpha, minimum of alpha 3 comma alpha 4 is 1, and minimum of alpha 2 comma alpha 3 is 2. So suppose let's say if alpha 3 is 1, so that means the second equation minimum of alpha 2 comma alpha 3, that won't be 2, because if minimum of alpha 3 comma alpha 4 is 1, that means either of alpha 3 is 1 or alpha 4 is 1. But if alpha 3 is 1, that means this minimum of alpha 2 comma alpha 3 will be 1, but we were already given that it is 2. So therefore alpha 3 is equals to 1 is not possible. That means alpha 4 is 1 for sure. And alpha 1 comma alpha 2, the minimum of alpha 1 comma alpha 2 itself is 3. So that means both alpha 1 and alpha 2 are at least greater than or equal to 3. So alpha 1 is greater than or equal to 3, and alpha 4 is equals to 1. So that means minimum of alpha 1 comma alpha 4 must be 1. Now in the second case, minimum of beta 2 comma beta 1 is 1. So that means either beta 1 must be 1 or beta 2 must be 1. Now suppose if beta 2 is 1, then minimum of beta 2 comma beta 3 won't be 2. So therefore beta 2 can't be 1, so that implies beta 1 is 1. And here this implies beta 4 is at least 3, because minimum of beta 3 comma beta 4 is 3. So that means this is minimum of beta 4 comma beta 1 must be 1. So this will give us some idea about the GCD. So we have GCD of D comma A as 2 to the power minimum of alpha 1 comma alpha 4, 3 to the power minimum of beta 1 comma beta 4. So that means 2 to the power 1 into 3 to the power 1 into K, where GCD of 2 and K is 1, and GCD of 3 and K is also 1. So that is 6K. And we were given that the 6K is in between 70 and 100. So that means this 6K can be 72, 78, 84, 90 or 96. Now if it is 72, that means it is 6 into 12, this is 6 into 13, 6 into 14, 6 into 15 and 6 into 16. So basically K value here is 12, 13, 14, 15 and 16. So if we consider GCD of 2 and 12, so here it is not equals to 1. Here also GCD of 2 and 14 is not equals to 1. GCD of 3 and 15 is not equals to 1. GCD of 2 and 16 also is not equals to 1. So these all are not our possibilities. If we consider here GCD of 2 and 13 is 1, and GCD of 3 and 13 is also 1. So that means 78 is the GCD of D and A. So that means 78 divides both the D and A. That means 78 divides A as well. So if 78 divides A, so that means 13 also divides A. So therefore this 13 must be the divisor of A. So that's it for this video. We'll meet in the next video.